Now let's see some more questions in permutations, in arrangement, subsequence, substrings, permutation with repeated elements. Let's see some more questions. Tell me what is the answer. Quickly tell me what is the answer. In how many ways can letters of the word mammal can be arranged? And this is a simple question, you already know. So this is your word mammal. Okay, so in this word I have 3M. I have 3M, I have 2 A's, and I have 1 L. So method 1 is direct method. Method 1, you apply the direct formula, your favorite formula. Apply the direct formula, your favorite. This is your favorite formula from your childhood. Okay, 3 factorial, 2 factorial, 1 factorial. Method 2. See, this method will not help you. This formula will not help you if some restriction is given, if some additional condition is given. If some additional condition is given, this formula will not help you. So you should understand method 2. Okay, what is the method 2? Method 2 is total 6 positions we have, right? Total how many positions? 1, 2, 3, 4, 5, 6. Total 6 positions we have. Okay, from 6 positions, select 3 positions for M. Select 3 positions for M. Select 3 positions for M. How many ways M can arrange? Now tell me how many ways M can arrange. From 6 positions, select 3 positions for M. Now how many ways? Now you are selecting 3 positions. Now M can arrange in only one way. Only one way for M. From the remaining 3 positions, you select 2 positions for A's. You select 2 positions for A's. You select 2 positions for A's. Now A can arrange in only one way. And then the remaining, in the remaining position, L will go. In the remaining position, automatically L will go. In the remaining position. Okay. You can notice this is same as 6 factorial divided by 3 factorial, 2 factorial. Both are same. Okay. So this is the idea. This is your method number 2. And you know the method number 3, that is division rule. The method 3 is division rule. You know, if all were different, 6 factorial, if all were different, if all letters distinct, our life will be easy. We will have 6 factorial. Life is good if all letters are distinct. If all of them are different, then answer will be 6 factorial. But you can notice because of these 3M, okay, they can arrange in 3 factorial ways. These 3M, they can arrange in 3 factorial ways. If all letters are distinct, then these M can arrange in 3 factorial ways, and these two A's can arrange in 2 factorial ways. So I can say this is divided by 3 factorial, 2 factorial, because same thing. Okay, same thing you have counted 3 factorial into 2 factorial times. These M they can arrange in 3 factorial way. A1, A2 they can arrange in 2 factorial way. So this will be your answer. Actually, the best method is method 2. Yes or no? Can you see the best method is actually method 2? If some additional condition is given, then the best method is method 2. Let's solve some questions with additional conditions. Tell me what is the answer. How many ways the letters of word permutation can be arranged? Permutations. So here we have 2T. Only we have 2 T's. We have 2 T's. Nothing else is repeating, right? Yes or no? Nothing else is repeating, correct? So I can say we have total 12 factorial divided by 2 factorial. This will be the answer, because nothing else is repeating. So this will be your answer. Or what you can do, method 2. What is method 2? From 12 positions, there are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From 12, you select 2 for T. You select two 40s. You select two 40s, and then the remaining people can arrange in 10 factorial ways. The remaining people can arrange in 10 factorial ways. This is for remaining. The remaining people can arrange in 10 factorial ways because they have no restriction. They can arrange in 10 factorial ways. Let's see this question. How many, okay, permutations, how many ways can the letters can be arranged? The letters can be arranged if there are always 4 letters between P and S. If there are always 4 letters, exactly 4 letters, how will you solve it? What do you think? What are you thinking? What is your thought process? Anyone want to tell me what is your thought process? There is additional condition here. So there are total 12 positions. There are total 12 positions. P comma S should have 4 between them. There are total 12 positions. Okay, there are total 12 positions. P comma S, they should have 4 between them. So for P comma S, how many situations are possible? Remember, for P comma S, they should have 4 between them. This is also possible. This is also possible. Okay, both are possible. Both are possible, no problem. They must have 4 between them. So first you select for P comma S. First you make sure for P comma S, you select 2 positions. How many ways to select 2 positions for P comma S? You select, first you put P comma S. Okay, let's just put P comma S. Let's directly put P comma S. How many choices for P comma S? They must have exactly 4 between them. They must have exactly, no, 12C2 is wrong. How can you say 12C2? Can you select these positions? There are 12 positions. There are 12 positions, 1, 2, 3, and so on, 12. Can you select these 2 positions? Can you select these 2 positions for P comma S? Can you select? Tell me please. Can you select these 2 positions for P comma S? No. 12C2 is wrong. 12C2 is wrong. How many ways for P comma S? For P comma S, I can say it's like this. Okay, for P comma S. Let's understand. So there are total 12 positions. So you can notice that if this position is selected for P comma S, then what another position will be selected? What another position will be selected? 6. Yes or no? With 1, you have to take 6. With 1, you have to take 6. Okay, with 1, you have to take 6. With 2, you have to take 7. Okay, and so on, and so on. With 12, what you have to take? With 12, what you have to take? 1, 2, 3, 4, 7. So how many ways? Tell me how many ways for P comma S? For P comma S, we have total 7. Yes or no? 7 choices. 7 choices for P comma S. 7 choices. In these 7, this P comma S, they can arrange in 2 factorial ways or 2 ways. Yes or no? In these 7, P comma S can arrange in 2 ways. Yes or no? So there are 7 choices. There are 7 choices. For each choice, P comma S can be put in 2 ways. Can be put in 2 ways. I hope this is clear to everyone. So this is for P comma S. Now P comma S is done. Now P comma S is done. So for example, maybe if P is here, then then this, if 2, then this will be in the 7. In the 7, S will be here. So P comma S is done. Now what about the remaining? What about the remaining? Now what about the remaining? So now P comma S is done, and the remaining 10 people, but they have two T's. Remaining 10 people. Now it is very simple. Now the remaining 10 people, 10 factorial divided by 2 factorial. The remaining 10 people. This is for remaining 10 people. This is for remaining 10 people. This is for remaining 10 letters because they have 2 T's. This 2 factorial because of 2 T's. Because there are 2 T's. So this is your answer. Is this clear to everyone? So this is your question. So can you notice that there can be some additional restriction can be there. So here we have a restriction for p comma s. We have a restriction. First you put this p comma s. Okay, just get rid of p comma s. Now p comma s is done. The remaining 10 people, they can arrange in 10 factorial divided by 2 factorial ways. Very simple. Tell me what is the answer here. The number of permutations of word A, B, C, D, E, F containing ABC substring. Containing ABC substring. This we have already seen. So you can put ABC in a box. This ABC you can put in a box. And then we have ABC, D, E, F. So this ABC you can put in a box. Then finally answer will be 4 factorial. Okay, the answer will be 4 factorial. Now what is the answer for this question? Number of permutations of 6 people. Number of permutations of 6 people such that 2 people A comma B, they stand next to each other. They stand next to each other. So 2 people A comma B. So total 6 people you have. A comma B comma C comma D comma E comma F. They must stand next to each other. So put them in a box. Put them in a box. So 5 people can arrange in 5 factorial ways. But remember, these 2 people can arrange in 2 factorial ways now. This 2 factorial is for A comma B. This is for A comma B. Yes or no? Is this clear? See, put them in a box. Put them in a box. So 5 factorial multiplied by 2 factorial because of A comma B. For A comma B, they can arrange in AB or they can arrange in BA. There are 2 ways for A comma B. But this will not happen here in the previous question. In the previous question, we want a substring ABC. Okay, so remember, this is fine. A, B, C, D, F, E. This is fine, but this is not fine. Okay, this is fine, but now this is not fine. So they ABC, this ABC, they can only stay in only one way. Only one way for them. They should stay in this order. Only one way for them. Okay, let's see the next question. In how many ways the letters of wondering be arranged with all 3 vowels consecutively appearing? There is a condition. With all 3 vowels, there are total 3 vowels. O, okay, these are the 3 vowels. All 3 vowels consecutively appearing. They should appear consecutively. So what will be the answer? The answer will be what? Put them in a box. O, I, E. Put them in a box. Then you have W and D, R and G. Okay, so 1, 2, 3, 4, 5, 6, 7. So the answer will be 7 factorial multiplied by 3 factorial. This 3 factorial is 4 O, I, E. They can arrange in 3 factorial ways. Yes or no? They can arrange in 3 factorial way, and divided by 2 factorial. Divided by 2 factorial. This 2 factorial we are dividing because of n. Because of n, we are dividing by 2 factorial. This is 4 n's. Okay, is this clear? Because there are 2 n's. There are 2 n's. So finally, I can say these OIE, they must be together. So 7 factorial divided by 2 factorial because of this n and this 3 factorial. Is this clear? Is this clear to everyone? What we are doing? Because they should be together. They should be together. So put them in a box. Put them in a box. They should be together. And this, don't forget about this. So the answer is what? So the answer is 7 factorial, 3 factorial divided by 2 factorial. This will be the answer. Okay, do not forget about n. Please do not forget about n. Next, what is the answer for this? How many ways A, B, C, D, E, F, G can be arranged such that A, B are never next to each other? Means they are never together. So what we do? So what we do? Arrange the remaining people. Arrange the remaining people. How many remaining people? 1, 2, 3, 4, 5. So arrange 5 people, 5 factorial ways. For this is for remaining. This is for remaining. Okay. Now there are total 6 gaps. There are total 6 gaps. You choose two for A comma B. For A comma B. So there are 6 gaps. You choose 2 for A comma B. Yes or no? So this, because when few people are never next to each other, never next to each other, so you can arrange the remaining people. There will be 6 gaps, right? Because you have C, D, E, F, G. How many gaps you have? 1, 2, 3, 4, 5, 6. So there are total 6 gaps. From these 6 gaps, you can select 2 for A comma B. This we have already done. This template we have already seen. Yes or no? Do you remember? This template we have already seen. So this is your answer. So you can select, sorry, yeah, you can select 2 for A comma B, and in, okay, just multiplied by 2 factorial, because once you select 2 gaps, once you select 2 gaps, once you select 2 gaps like this and this, once you select 2 gaps, they can arrange in 2 factorial ways. Once you select 2 gaps, they can arrange in 2 factorial ways, A, B, B, A. Okay, so this will be the answer. So this is the idea. So finally here answer will be basically 5 factorial into 6p2. 5 factorial, so I can say 5 factorial multiplied by 6p2, because there are 6 gaps. In 6 gaps you can permute, you can permute 2 people which are A comma B. Okay, is this clear? So total 5 factorial. This is for remaining. This is for remaining. This is for remaining people. There are 6 gaps. In these 6 gaps, you can select 2 gaps and you can permute. Basically, in 6 gaps, you can permute. Tell me what is the answer here. In how many ways can the letters of wondering be arranged with exactly 2 consecutive vowels? Exactly 2 consecutive vowels. Means it should not happen that all the 3 vowels are consecutive. It should not happen that all the vowels are consecutive. It should not happen. It should not happen that all the vowels are consecutive. Exactly 2 consecutive vowels you should have. Exactly. This word exactly. This word exactly. So tell me, is this correct? Like, okay, is this answer correct? If I do this, is this correct? Can I do this? No, I cannot do this because it should not happen. You should have exactly 2, okay, exactly 2 consecutive vowels. Can I do this? Can I do this? Can I do this? This is also not possible because you must have exactly 2 consecutive vowels. So for example, you can have like this. Like this you can do. This is fine. Okay, so this is the question. So tell me what is the answer. So this is what you have. What you can do, you can select who 2 vowel would be together. First you select which 2 vowel together. First you select which 2 vowel together. First you select which 2 vowel together. Just select this. Total 3 vowels you have. Which 2 of them together? So there are 3. Which 2 of, select 2 of them. Select 2 of them. Which 2 vowels are together? For example, maybe U comma O comma U are together. O comma U, they are together. Now put them in a box. Now put them in a box. Now what you do? Now you put them in a box. So now I have put O comma U in a box. This is what I have done. Put them in a box. After putting them in a box, what you can say? What you can say? That this comma I should not be together. Never together. They should never together. They should never be together. Yes or no? Now this O comma, this box comma I, they should never be together. So very simple. First you arrange remaining. The remaining people, how many? One, total 6. Total 6 remaining people you have. So first you arrange 6 remaining people in 6 factorial divided by 2 factorial. This is for remaining people. First you arrange them 6 factorial divided by 2 factorial. So first you just arrange the remaining people. Now there are how many gaps? Total how many gaps? You have total 7 gaps. You have total 7 gaps. So there are 7 gaps. In those 7 gaps, you can permute. You can permute this box comma I. This box comma I you can permute. But remember, O comma U also can permute in 2 factorial ways. Yes or no? This O comma U, they can also permute in 2 factorial ways. Is this clear? Tell me. Is this question clear? See, very step by step you go. Basically, 2 vowels should be together. So first you decide who will be together. Which 2 vowels should be together. Okay, so from 3 vowels, you select 2 vowels. These 2 vowels should be together. But they can be in 2 factorial ways. These 2 vowels can be in 2 factorial ways. O comma U, U comma O. Okay, now put them in a box. Put them in a box. Now what you can do? Now you can notice that the remaining people, they can arrange in 6 factorial divided by 2 factorial ways. This is what remaining people will do. And remember, this box and I, they should never be together. So from the 7 gaps, you can select 2. You can select 2 for, okay, and you can permute I comma U, I comma U, I comma OU. This is what you can do. Is this clear? Is this point clear to everyone? So this is the answer. Okay, next. What is the number of permutations of word A, B, C, D, E, F in which A comes before B? Not necessarily immediately. This question, we have already seen this question. Do you remember? In the product rule. This question we have already seen in the product rule. Okay, now let's see. So what is the answer? What is the answer? Now this same question we can solve by a different method. So you have A, B, C, D, E, F. A comes before B. Basically means that you have A, B subsequence. This A, B subsequence you have. A, B, C, D, E, F. With A, B subsequence. With A, B subsequence. You must have A, B subsequence. Then what I can do? See the method, the division rule. Either you can apply the division rule. Method 1, division rule. Method 1 is division rule. We have already seen this division rule. So either you can apply division rule, but I will give you a better way. So you can apply division rule. If this condition was not there, then 6 factorial. Because of this condition, we will divide by 2 factorial. This we have already seen. I will not explain. You can watch the division rule video. I have already. But let's see a good method, like a better method. A better method. Let me tell you one thing. The division rule is nice, but you can solve all these questions using different methods also. Okay, so let's apply the different method. So total how many positions you have? 6 positions, right? Total you have 6 positions. 1, 2, 3, 4, 5, 6. From 6 positions, you select 2 positions for A comma B. For A comma B, you select 2 positions for A comma B. Once you select 2 positions, how many ways they can arrange? How many ways they can put? How many ways you can put them? Only in one way. Yes or no? Only in one way. Correct or not? Okay, first you select 2 positions. First you select 2 positions for A comma B. 2 positions you are selecting. First you select 2 positions. After selecting these positions, they can arrange in only one way. Only one way. The remaining 4 people can arrange in 4 factorial ways. So the answer is 6 factorial divided by 2 factorial. Both are same. This method is better. Yes or no? This method is better. Can I say this method is better? This is very nice method. That first you just select 2 positions for A comma B. Put them in only one way for them to put. And then the remaining people in 4 factorial ways. Very simple, extremely simple. Or what you can do? Another method. See the method number 3. Okay, just understand this method also. This will help you in many questions. This method. A, B, C, D, E, F. You know that, okay, for A comma B, if I have to, if I select 2 positions for A comma B, if I select 2 positions, then how many ways they can arrange? They can only arrange in one way. They can only arrange in one way. So what I can do, can I consider them same? So what you can do, very simple, that just consider them same. Because if you have, like, if you have two same people, then how many ways they can arrange? If you have same people, two same people you have, then how many ways they can arrange? Only one way. So what you can do, because for A comma B, once you find position, they can only arrange in one way. So you can consider them as same. So this question you can change, and this question will become like this. Basically, you have A, C, D, E, F. Now you have this question. So answer will be 6 factorial divided by 2 factorial. So your question is changing. Now you have changed the question. You are changing the question. What you are saying? You are saying that if you have this A comma B, anyway, this restriction we have. Once you select two position for A comma B, only one way they can go. Only one way they can go. So you can consider them same. Because anyway, if you have two same people, they can also go in only one way. So finally, what you can do, okay, this is the same idea, that you can consider them same, and then finally this is 6 factorial divided by 2 factorial. Very simple. Just permute them. Very simple. Yes or no? Is this clear to everyone? Tell me answer for this. What is the answer for this question? Number of permutations of word A, B, C, D, E, F. A comes before B and B comes before C. Basically what I want, I want ABC subsequence. I want ABC subsequence. A should come before B, B should come before C. I want ABC subsequence. So this A, B, C, D, E, F I have, and I want with ABC subsequence. This is subsequence I want. This subsequence I want. Okay, so what, very simple. There are total 6 positions. Like this you can do. You can do like this. There are total 6 positions. You can select 3 positions for A comma B comma C. For ABC, you select 3 positions. Once you select 3 positions for ABC, how many ways they can go? How many ways they can go? Only one way they can go. Only one way they can go. The remaining 3 people can arrange in 3 factorial ways. Okay. Another method, method number 2. What is that? Method number 2. Method number 2 is you can consider them same anyway for A comma B comma C. For A comma B comma C. Once you select 3 positions, only one way we have. Only one way. Only one way we have. So you can consider them as same, like A. You can consider like this. You can consider like this, A. So finally, now you are changing the question and you are saying A, D, E, F. So how many permutations you can create? 6 factorial divided by 3 factorial. Method 1, method 2, like which is your favorite? I personally like method 1. Let me, actually, this is my favorite method, method 1. Okay. I'm just telling you method 2 because just to give you another perspective. Okay, but method 1 is actually good. Like, okay, this is a very systematic method. Method 1. It is a very systematic method that there are 6 positions. You select 3 positions. In those 3 positions, how many ways you can put ABC? In those 3 positions, you can put them in only one way. The remaining 3 people can arrange in 3 factorial ways. So this method 2 is more systematic. Sorry, this method 1. This method 1 is more systematic. Okay, anyway, let's move on. So tell me the answer for this now. I am taking all the variations. You can check every variation. I am taking many variations. I am taking. So again, now you have A comes before B and C comes before D. So I want AB subsequence, CD subsequence. You should have AB. You should have CD. Now what is the answer? You must, okay. So A, B, C, D, E, F. A, B, C, D, E, F. You must have AB. Okay, like A should come before B. Basically, A should come before B. C should come before C. C should come before D. This is what you want. So the method one, just apply the method one. There are 6 positions. Select 2 positions for A, comma B. Select 2 positions for A, comma B. How many ways they can put? In only one way. How many ways you can put them? In only one way. There are 6 positions. So from these 6 positions, you select 2 positions for A, comma B. You can put only in one way. From the remaining, you select 2 for CD. You select 2 for CD. You select 2 for CD. In how many ways I can put them? Only one way. Only one way. The remaining 2 people in 2 factorial ways. What is your method 2? What is your method 2? What is your method 2? You can consider this AB as same. This AB you can consider as AA. This CD you can consider as CC. So finally we have AA, CC, EF. Okay, so for this answer will be 4 factorial divided by 2 factorial, 2 factorial. Yes, this will be 6 factorial. This will be 6 factorial. One more question let me ask. So let's assume you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's assume this is what you have. So how many permutations? How many permutations you have? So I want permutations with 1, 2, 3, with 1, 2, 3, comma 5, 6 subsequence. So what will be the answer? I want these two subsequences. I want permutations. I want permutations with 1, 2, 3, comma 5, 6 subsequence. So very simple. The answer is, so from 9 you select 3. You select 3 for 1, 2, 3. For 1, 2, 3. They can arrange in only one way. They can arrange in only one way. From the remaining 6, you select 2 for 5, comma 6. You select 2 for 5, comma 6. The remaining 4 people can arrange. The remaining, how many people? 4 people can arrange in 4 factorial ways. Okay, and this is same as 9 factorial divided by 3 factorial, 2 factorial. This is same as 9 factorial divided by 3 factorial, 2 factorial, because you can consider them 1, 1, 1. From where this answer is coming, you can consider as 1, 1, 1. Then you can consider 4. Then you can consider 5, 5. Then you can consider 7, 8, 9. Like this you can consider. Okay, so very simple. What will be the answer for this question? Now we have immediately, like A always comes before B immediately. C comes before D immediately. So what I want, can anyone tell me, do I want subsequence? Do I want subsequence? No, I want substring. I want substring. I want AB, CD substring. I want AB, CD substring. This is what I want. Okay, so you have 4 letters A, B, C, D. So basically these 4 letters you have. These 2 are in a box. They must be in a box. They must be in a box. So the answer is 2 factorial. So what will be the answer? Answer will be 2 factorial. Just put them in a box, because I want AB substring, CD substring. These 2 substring I want. So the answer will be 2 factorial. Let's see this. How many permutations? So what is the answer here? What will be the answer for this? Permutation of few elements in a particular order. See, permutation of few elements in a particular order. So this is basically, you have a conference, 10 speakers. S1 wants to speak before S2. S2 wants to speak before S3. Number of ways 10 speakers can give. So this is, now I hope this is very easy now. 10 factorial divided by 3 factorial. Now this is very easy, you know, because you have S1. So these are the speakers, S1, S2, S3. These are the speakers. So basically it's like this. So total 10 positions you have. From those you select 3 positions. From those you select 3 positions for S1, S2, S3. They can arrange in how many ways? You select 3 positions for them. They can arrange in how many ways? One way. The remaining can arrange in 7 factorial ways. So this is your 10 factorial divided by 3 factorial. Okay, next, what is the answer for this? There are 10 speakers, S1 to S10. S1 speaks only after S2 has spoken. Means basically this is also same as basically S2 S1 should speak after S1 should speak after S2. So here the answer will be 10 factorial divided by 2 factorial. Or you can do like this. From 10 you select 2. From 10 you select 2 for S1, S2. For S1, S2. They can arrange in only one way. The remaining 8 people can arrange in 8 factorial ways. Quite simple, these questions. Now these questions are very simple, right? Let's see this question. How many permutations? I have taken all the variations, let me tell you. Like on the Stake Exchange website, all these questions, these are from Stake Exchange, Stake Overflow. Okay, I have taken all the variations. Just back to back, I have taken all the variations. So just understand them and you will be very good in combinatorics. Okay, next, how many permutations of this exist that follow these rules? These rules must be there. 5 must come first. 8 must come before 9 and 7. 2 must come before 1. Okay. Now this is the question where you will find the importance of this method. This method 1 importance you will find here. See, I told you method 1 is nice. I told you method 1 is nice. The importance of method 1 you will find in this question. Okay, let's do this question. So the question is saying how many permutations of this you want? 5 must come first. See, because of this, just forget about 5, right? Yes or no? 5 is done. Yes or no? Forget about 5. 5 is done now because 5 must be the first position. So forget about 5. Okay. You don't have to worry about 5. 5 must come first. So 5 is already in the first position. No, don't worry about 5. So now your question is only this. This is your question now. 8 should come before 9, 7. So from these 5 positions, there are 5 positions. From these 5 positions, you select 3 positions. For 8, 9, 7. How many ways they can arrange? Tell me. Tell me, please. How many ways they can arrange? 8 should come before 9 and 7, or 8 should come like this. So there are 2 ways. So this 2 you are getting. This 2 you are getting because of this. Yes, correct. So from 5 positions you select 3 positions for 8, 9, 7. They can arrange in 2 ways. Okay, 2 must come before. So now from the remaining 2 positions, you select 2 positions for 1, 2, and they can arrange in only one way. That's it. That's it. This is your question. Is this clear to everyone? In this question, you can find the importance of this this method 1. Method 1 importance you can find in this question. Let's solve one more question. Okay, so you have this 1, 2, 3, 4, 5, 6, 7, 8, 9. I want permutations. Remember, I want permutations in which 4 comes before 1, 2, 9. 4 comes before 1, 2, 9, 8. Okay, let's see this. This is what I want. I want permutations in which 4 comes before 1, 2, 9, 8. What will be the answer? Now you can do it very simple. So from 9 positions, you select total 5 positions for 4, 1, 2, 8, 9. How many ways they can arrange? They can arrange in 4 factorial ways. They can arrange in 4 factorial ways. The remaining 4 people can arrange in 4 factorial ways. Is this clear? So Like this you can do, right? Yes or no? Very simple. So these five people can arrange. These five people can arrange in 4 factorial ways. In 4 factorial ways. And the remaining 4 people, they can arrange in 4 factorial ways. Next, let's see this one. In how many ways the letters of rainbow arranged such that A is always before I is always before O? This is now very simple. Now this has become very trivial question, right? This has become a very trivial question now. Now these are okay. So for A comma O comma I, they can arrange in only one way, and the remaining 4 people can arrange in 4 factorial ways. Next, okay, let's solve this one. Let's solve this question. This is a question from some university. So this is a nice question. So try this. Subsequence definition is given. This is the definition of subsequence we already know. For example, ABD is a subsequence of this. Okay, ABD is a subsequence. If you delete them, then you will get ABD. But you can notice that, right? If you remove these, then you will get ABD. Okay, this is the definition of subsequence. Assume each permutation of letters A, B, C, D, E, F, G, H. Define a sequence. How many ways sequence contains subsequence this or this? Either CAB or BED. Either you have CAB subsequence, either you have CAB subsequence, or you have BED subsequence. So either you have CAB. So with CAB subsequence, what is the answer with CAB subsequence? If you have CAB subsequence, then the answer is what? So total 8 people. So that will be 8 factorial divided by 3 factorial. With this subsequence BED, with this subsequence, this or this, so that will be 8 factorial divided by 3 factorial. So is this correct answer? Is this answer correct? Is this answer correct? No, these are not disjoint. These are not disjoint. This subsequence, what they have common? What they have common? When, okay, see, when it is possible that they both have, okay, it is only possible. You have CAB, you also have BED. So this subsequence you have. This subsequence you have. So the answer is 8 factorial divided by 5 factorial. So the answer will be this. From these you remove this. This will be your answer. Okay. 8 factorial divided by 3 factorial plus 8 factorial divided by 3 factorial minus 8 factorial divided by 3 factorial. I hope this is done. Okay, so all these variations, are they clear? If all these variations are clear, then you are very good in permutation combination. Anyone who got all the variations that we have seen, then you can guarantee that you are very good in permutation combination, product rule, division rule, everything that we have seen so far. We have taken variation. Okay, we have taken all the possible questions, restrictions, conditions, different methods, everything we have seen.